In this video, we're going to create a JPA DAO in Spring Boot. Okay, so looking at our application architecture, and we'll make use of the JPA API, the standard JPA API, and we'll focus on that in this video. All right, so here's our development process. So we have our long list of items that we need to perform for our CRUD operations. And what we'll do is we'll build a DAO layer for this. And in this scenario, we'll make use of the standard JPA API throughout. All right, so let's go ahead and look at a DAO implementation. So I'll create this employee DAO JPA implements the employee DAO interface. I'm using the same interface so we have a consistent API. I'll make use of our field here, private entity manager. And then I'll set up a constructor here. And remember that the entity manager is automatically created by Spring Boot. And this is just an example here of making use of constructor injection for that entity manager. Okay, so let's go ahead and look at some of the methods here. So to get a list of employees using the standard JPA API, and then I go ahead and create a query. So I'll say entity manager.create query, make use of my JPQL from employee, and I give the employee.class. I go ahead and execute the query and get the result list. And then finally, I return the results or return the employees. And that's basically it. And here we're using the standard JPA API throughout. This is all standard code here. Alrighty, so let's go ahead and look at the development process here for our DAO. The first thing we'll do is update our database configs in the application.properties. Then we'll create the employee entity. Next, we'll create the DAO interface. We'll create the impl, and then we'll actually create a REST controller to use the DAO. And we'll cover all of that in some of the following videos. Now let's go ahead and move over to our IntelliJ preferences here, and we'll set up those IntelliJ configurations. And let's move down to the item here for build, execution, deployment. Expand this for a second, and then we'll choose compiler. And then we'll select this checkbox here, build project automatically. Alrighty, so that looks pretty good. Let's go ahead and click on the apply button. And now let's go and select the advanced settings item. And then in the compiler section, we'll check the box, allow auto make to start. And remember, these are the little IntelliJ configurations that we need to do for the community edition to allow it to work with Spring Boot Dev Tools. Okay, so with our development process, we'll focus on the first two steps here of updating the database configs and the app properties, and also creating our employee entity. Alrighty, so let's go ahead and get started with step one of updating our database configs. And remember, in Spring Boot, we have this special properties file, application.properties, and that file resides in your source main resources directory. So let's go ahead and open up this file and zoom over a bit. And so right now this file is empty, and so this is where I'll add my data source properties. So I'll add an entry here for the Spring data source URL, and I'll give a URL to my database. Zoom out a bit here so we can see a bit better. And then we simply go through and we add our Spring data source username and also password. And that's the database connection information for our given user account. I'll just do a quick copy paste here on this first line, paste it, and then just update the property name for password. And you may need to update this accordingly based on your local environment if you have different user IDs or passwords for your local database. And then remember, Spring Boot will automatically create the beans for data source and entity manager, and we can inject those into our application. Okay, so let's go ahead and move to our root package, and we'll actually create a new package. And this package is to actually hold our entity. So I'll just say .entity. And now I'll actually go through and create the employee entity in that package. So I'll just create a new class here. For the class, I give employee as the name. Let me expand my window here. So what we need to do here is just create an entity and map this entity to our given database table. So we make use of the @entity annotation and also the actual table annotation. We map it to our given table employee. And now what I'll do is I'll just write some quick comments to myself just so I know what I need to create in this given file. Alrighty, so basically I need to define fields, define constructors, define getters and setters, and also define a toString method. Alright, this looks pretty good. Let's go ahead and get down to business. So I'll start here with defining the fields. So I'll set up a field for ID, first name, last name, and email. And now I need to add the annotations here for each one of the fields. So my ID is the primary key, so I make use of the @ID and generated value. And we've seen all this coding before. And now I'll make use of the @column annotation to map these fields to a given database column name. So I'll set up first name, and I'll actually just copy this line and then move down and paste it. And I'll just update the name there. And ooh, I see a silly typo. Ooh, wow. So this actually has to be the column name. So that means it has to be first underscore name. Ooh, that's scary. Glad I caught that one. And a similar thing here for last name. Last underscore name. Okay, so this looks pretty good. That's all the work here for defining the fields for this employee entity. Okay, so we can move down to this next section here of defining constructors. And I'll start off here by just creating a no argument constructor. And now I'll also create a constructor using the fields. So I use a source generate constructor. And I'll select all of them except ID, because ID is going to be automatically generated. So have first name, last name, and email. So those are the three that you should have selected for this example. Okay, this is great. So those are our constructors here for this employee entity. Good job. All right, now just more of the same, right? You know how to do all this stuff, just defining the getters and setters. So we'll actually have the IDE generate these for us. So we simply go to source, generate getters and setters. Just do a select all here. Okay, great. Now let's clean up some white space here and let's define our toString method. And again, just using the IDE to generate that for us. But there we go. We're in pretty good shape there with our toString method. And we're almost done. However, there's another silly typo. So if we move up here to our field for email, notice the annotation for column. It says first name. That's incorrect. We actually need to make use of the column name email. So let's go ahead and make this update. Okay, so moving along with our development process, we'll focus on steps 3 and 4 of creating the DAO interface and the implementation. So the first thing we should do is create a new package here for our DAO. And of course, the name that we'll give for the package is DAO. Okay, so there's our new DAO package. So let's go ahead and create our DAO interface. So just do a new interface. And the name we'll give here is employee DAO. Okay, so let me expand my window here for a bit. And so to get started, this DAO will simply have just one method, just to get things up and running. We'll add more functionality in some of the later videos. So we'll simply add this method here, find all, that'll return a list of employees. All right, so with our next step here is creating the DAO implementation. So I'll move back to my DAO package and I'll just create a new class. Okay, great. So it created this class for us. Let me expand this window here. Implements employee DAO. Okay, that's good so far. I like it. Now I need to mark this or annotate this as @repository. So what I need to do here is define the field for entity manager and also set up constructor injection. I'll set up the constructor injection with the auto wired and an actual constructor. And I provide item or the bean that we want to inject here. So the entity manager. And simply do an assignment. Remember, the entity manager is automatically created by Spring Boot, and we can simply inject it here into our application. Okay, so let's go ahead and move down to this find all method. And I'll write some quick comments here to myself. And so this is kind of our basic game plan here for finding all of the employees. Okay, so let's go ahead and just write the coding here for creating a query. So I use entity manager.create query, and I'll say from employee. Now we just go through and execute the query and get the result list. And then finally, we return results or return the employees. And this is basically it for using the standard JPA API. Very simple, very straightforward. Okay, so we're almost done. So our final step here is creating our REST controller to use our DAO. And the first thing I want to do here is actually create a new package. And so this will be a package for holding our REST controllers. So we'll give the name of the package .rest. Okay, so now we have our new package. The next step is creating the REST controller to use our DAO. So I'll just create a new class here. And the name of the class, I'll call it Employee REST Controller. Let me expand the window here. And now I'll write some quick comments to myself. So we'll do a quick and dirty solution. We'll inject the employee DAO directly. We'll refactor this later with the service layer, but for now, we'll just put it in here so we can run some examples. And then also we'll expose the employees endpoint that'll actually return all the employees. We'll just give our annotations up top for REST controller and request mapping. So the base mapping will be /API. So I'll define the field here for the employee DAO. And now I'll set up constructor injection here to inject that employee DAO. Alrighty, so that's our constructor then. We're using constructor injection here. Okay, so let's go ahead and write the code to return a list of employees. So I'll simply set up a get mapping for /employees. And I simply write the code here for this find all that returns a list of employees. And I simply delegate the call to my DAO. So I'll say employee DAO.find all. And that's the basic coding there to return a list of employees. All right, so that's the basic coding there for our controller. We simply define the field, we set up constructor injection, and then we expose that endpoint to return a list of employees. Very simple, very straightforward. And now I'm getting excited here. I think I'm ready to run it. So let's go ahead and move to our CRUD demo application. That's our main Spring Boot application, and run it as an application. Excellent. So our app is now up and running. So let's go ahead and swing over to our browser. And let's visit the URL localhost 8080/API/employees. Yay, success. Good job. So we have data. Oh, this is all good stuff. So this is data that's coming from the database right now via our REST API. Woo, this is cool. I'm happy. But again, I always like to verify this, right? Like to go over to the MySQL workbench and actually do a query on the database to make sure that really is the right data. All right, so let's go ahead and move over to our tables here, our employee table, and just run a quick query here and verify the results. And yay, this works out as desired. So this is the real data that is coming from the database. So I'm happy, I'm excited, and we made some good progress here by building this REST API